Okay, we'll continue small signal analysis of a MOS amplifier. Now we know that all voltage amplifiers using transistors can be described as having a voltage gain that's equal to big GM times RT. Now, big GM is the total circuit transconductance, including all external components. These would be things like resistors that are tied to the gate, drain, and source of the transistor that's under analysis. RT is the total driving point resistance. So this is the resistance that the transconductance sees. What we mean by this is that the GM, the transconductance, is going to convert a voltage to current, and it's going to drive the current that it creates into the resistance RT. With the current flowing through RT, a voltage will develop, so that RT is going to convert the current back to a voltage. Now, the amplifier that we just looked at in the prior example was a common drain amplifier. Sometimes the common drain amplifier is called a source follower. And the source follower is a type of amplifier where the source follows whatever's happening at the gate, more or less. And these are commonly used as voltage buffers. They can't actually have high voltage gain. In fact, their voltage gain will always be less than unity, but it can approach unity, which makes it a good buffer. Now we can note that big GM for that source follower was equal to little gm, this is the GM of the transistor, divided by 1 plus GM times RS in parallel with RL. RS in parallel with RL is the total resistance seen at the source of the transistor. And RT, the total resistance, is equal to RS in parallel with RL. All right, in the next video, we're going to do another example amplifier, and we'll look at another example amplifier and see if we can calculate what the voltage gain of that amplifier is, and maybe put it into the context of finding the gain in terms of big GM and big RT.